The MCAT Podcast, session number 107. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT Podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help you get the score you deserve so you can one day call yourself a physician. Now, welcome to the MCAT Podcast. My name is Dr. Ryan Gray, and as always, I am joined by Brian Snedeker from Next Step Test Prep, and we are going to jump in and continue our full-length 10 breakdown. All right, Brian, as we mentioned in the last episode, we had to skip passage 10. It just wasn't amenable to being on the podcast as a good podcast episode. But we have our last set of discretes here before we move on to our next section. So I'll start with question 57. The addition of which of the following compounds to water would reduce the solubility of ferrous hydroxide? A, ammonia, B, ethanol, C, acetic acid, or D, trichloroethane? And I would do one of those where I would pick C and move on because I wouldn't remember it.
Sure. So it's just this is one of those ones, very, very short question, right? Not a lot of words. 3 scientific principles you've got to remember. Number 1, you've got to recognize ferrous hydroxide, right? That hydroxide should jump out as, hydroxide, OH minus. And so the first step of analysis here is that you have to recognize that's a base. Anything that creates hydroxide is a base. If memory serves, ferrous hydroxide is very, very sparingly soluble. So it's not much of a base, but it is still technically a base. Then the second fact you got to remember is that for solubility rules, acids and bases like to dissolve each other, right? They help each other dissolve because the OHs and the Hs just get together and make water.
They get together. I like that.
Yeah, they hook up. Yeah, it's a good time. There's there's Hootie and the Blowfish on the stereo and wine coolers all around. So it's that might be the most 90s sentence ever said out loud. But in that same vein, bases interfere with each other, right? If you try to dissolve multiple bases, they're going to make each other harder to dissolve. Acids would interfere with each other due to something called the common ion effect. So fact number 1, recognize hydroxide as a base. Fact number 2, remember that bases would interfere with each other trying to dissolve. They would reduce each other's solubility. And that's what it says here is reduce the solubility. And then fact number 3 is you just have to know which of these answer choices is the base. And that very first one there, ammonia, classic example of a weak base. The MCAT, when the MCAT wants to give a weak base, fair bet 7 times out of 10, 8 times out of 10, if they want a weak base, they're using ammonia. And so that's the right answer here.
Okay.
All right, number 58. Both eukaryotes and prokaryotes possess desaturases, which can increase membrane fluidity by adding a cis double bond to a fatty acid chain on a phospholipid. What's the primary intermolecular force acting between adjacent fatty acid chains in a cell membrane? London dispersion, hydrogen bonding, dipole-dipole, covalent bonds. Primary intermolecular force acting between adjacent fatty acid chains in a cell membrane.
I don't remember anything about molecular forces.
Sure, yeah, and why would you, right? Like once the MCAT is over, who cares?
That is a very, very rhetorical question because you don't need it at all to practice medicine.
Right. Yeah, and honestly, I mean, you need it to get through high school chemistry, college, freshman chemistry, and the MCAT, and then you're done, right? Yep. So summer after junior year, you finish up your MCAT, and then you can forget it for the remaining 50 years of your life. In this, or unless you're like me and you go into this stuff professionally. So first, it says intermolecular force. So you can eliminate covalent bonding. That's an intramolecular force. And then fatty acid chains are just big, long chains of hydrocarbons, which means the only intermolecular force that predominates for them is London dispersion. Hydrogen bonding requires hydrogen be bonded to fluorine, oxygen, or nitrogen, none of which is true in the tail part of a fatty acid chain. And dipole-dipole interactions require actual dipoles. Which again, you might have a little bit in a cis bond, but that's not the predominant one. The question was just asking with the primary force in a cell membrane, and overwhelmingly that's London dispersion.
All right. Question 59. Naturally mined uranium consists of two isotopes, U-235 and U-238. U-238 is more stable than U-235 and cannot be used for nuclear energy. An industrial enrichment process increases the abundance of U-235 from 0.9% to 3.7% in a 500-gram sample of uranium. How many additional moles of U-235 are yielded as a result? 7.8 times 10 to the negative 2 moles, 5.9 times 10 to the negative 2 moles, 7.8 times 10 to the negative 1 moles, or 5.9 times 10 to the negative 1 moles.
Yeah, but bunch of math here. It doesn't work quite so well for us to kind of talk through all the numbers, so I'm not even going to try. Instead, I'm just going to explain like the thought process that underlies a problem like this. So the first thing it said was we're going from 0.9% to 3.7% of a 500-gram sample. So that's the first bit of math you hang on to, right? So from 0.9 to 3.7 is 2.8% more in a 500-gram sample. So you would say, what's 2.8% of 500 grams? You do some math, you get whatever that number is. Turns out to be 14 grams. But then the question was in moles. So at that point, you're just converting grams to moles. And so you would do 14 grams divided by the U-235, right? So 235 is the molecular weight, the grams per mole. So 14 over 235, and whatever that comes out to, yada, 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 hand wave, and you get some math, and the answer's B. Folks can get the handout from the show notes, and they can actually crank the math out if they want and check that they're able to get answer choice B. But again, fundamentally 2 steps, right? Take that percentage increase on the 500-gram sample, and then multiply that grams by the divide that grams by molecular weight to get moles.
For quick math, so 14 divided by 235, is it possible to do like 10 divided by 235? Would you round up or round down to make the math a little bit easier to see if one of the answers jumps out faster?
Yeah, that's a really good question. So what you would do is you don't want to round that much because these answer choices are pretty close together, right? 7.8 times 10 to the minus 2 and 5.9, which is basically 6 times 10 to the minus 2. They are, I will say for the MCAT, these are remarkably close together. The MCAT usually spreads the answer choices out a little more, but you may get one like this where they expect you to grind out the math. So what you would do is you'd take 14 over 235 and you would round that slightly to 15 over 235. So then you could reduce by a factor of 5.
Okay.
So 15 over 235, what would it divide by 5? That becomes 3. 3 over 235, we have 4, carry the 3, 7. So that'd be 3 over 47. And that's also kind of ugly, right?
Yeah.
Like what's 3/47ths?
Yeah.
And then you could round that and say, well, 47 is pretty close to 50.
Yeah.
Right? So 3/50ths becomes 6 over 100.
Yep.
Roughly. So 0.06.
Yep.
So then, then the answer's got to be B or D, right? 5.9. That's pretty close to 6.
Okay.
And it's 10 to the minus 2, so 0.06.
All right. Yeah. So some easy rounding just to make the math easier.
Yep. Yeah. You always want to round something where you can reduce the fraction, and then try to round so that the denominator of the fraction gets as close as you can to either 100 or 50 or 25. Something you can just like scale to 100 to make it a percent.
Yep.
Very common technique for manipulating fractions without a calculator on test day.
All right, so there you have it. Some more Next Step Full Length 10. Did you know, I always ask this in my Facebook group, the Pre-Med Hangout. If you're not part of the Hangout, you should be. It's medicalschoolhq.net/group. It's a group of almost 6,000 collaborative, amazing pre-med students. It's an amazing community there. And I ask every once in a while, I'm like, tell me what you think about full-length exams. Who are you using? What do you like? And inevitably, you get a lot of people that will go with the purple big box company because they have a lot of marketing. And then you'll have a lot of students that time and time again say Next Step. Next Step is the best. Next Step was the tests that were closest to the real MCAT that I took. Next Step scores approximated the best, the score that I got on my MCAT. Next Step full-length exams are by far the best out there, according to you guys, according to the students, right? I haven't taken the MCAT in a long time. So for me to evaluate, all I can look at is, do the questions look good? Is the platform nice? All that stuff, of course. Yes, definitely. But to simulate the real exam as it is now, I took it back on paper way back in the day. But right now, I rely on you guys, and you guys tell me Next Step full lengths are the best. So go check them out. nextsteptestprep.com. Use the promo code MCATPOD. That's all capital letters, MCATPOD, for 10% off those full-length exams. If you're in the market for other stuff as well, you can use that code and save some money on anything that Next Step has to offer. Hope you have a great week. We'll see you next time here on the MCAT Podcast.